We're going to take a look at calculating confidence intervals now for means. This is from section 7.3 in this chapter about confidence intervals. Confidence intervals for means, in particular when we know the population standard deviation. Whether that's a realistic scenario or not is something that we'll talk about. But when we know the population standard deviation, we've got a way that we can compute these confidence intervals for a mean, for an average, for a population mean, based on sample information. All right, and the way that we'll do that is under the Stat menu, over to Tests, and we want to go down to the Intervals section, not the Tests section, but down to the Intervals section, starting at number 7. And number 7 is actually the one that we want, ZInterval. All right, this is a confidence interval for a mean. ZInterval is what we use because it uses the normal distribution. When we know the population standard deviation is when we'll do that one. We'll see T-interval probably in the next video. Okay, so when you do that, it gives you the option of inputting data or inputting statistics. If we have the entire list of data from our sample, then we can put that in there. If not, then hopefully we have some summary statistics that we can put in. So in this example that I want to do with you, we don't have the actual data itself. It says a sample of 75 babies born in the U.S. had a mean birth weight of 3,433 grams. Convert that to pounds if you're curious, but the birth weights of all babies, it says, have a standard deviation of 495 grams. That's our known standard deviation, sigma, the birth weight of standard deviation of the birth weight of all babies. And what we want to do with that is construct a 99% confidence interval for the average birth weight of babies born in the U.S. So we have this sample of 75. There's a lot more than 75 babies born in the U.S., even during a month, I'm sure. What we want to do is calculate a confidence interval for the mean birth weight of all babies born in the U.S. based on this sample. Okay, again, we don't have the original data itself. That's probably a good thing that we don't have all 75 birth weights there. If we did, we could go into Stat, Edit, enter those in the list, and go back to ZInterval, Tests, Stat, Test, ZInterval, and then put in our information there using list L1. All right, usually what we have for these problems are summary statistics, or even if you don't, you can calculate the sample mean pretty easily just by adding them up and dividing by n. So that's what we'll do this time. All right, so it asks for sigma first. We have to know that population standard deviation, and in this case that was 495. You'll notice that this one didn't say that we knew that we had a normal distribution. That was part of one of our requirements, but what we do have is a sample size that's larger than 30, and we'll note that once we get to the end part. So standard deviation 495 for our population. The average of our sample, x bar, is 3,433 grams. All right, our sample size was 75 weights that we had. And then our confidence level was 99%, 0.99, or again, if you put in 99, it'll understand what you mean there. Okay, again, note that sample size is greater than 30. That's what allows us to use this method for a confidence interval, even though we don't know that the population that we're drawing this sample from was a normal distribution. That's the other guideline if our sample size were smaller than 30. All right, so we'll go to Calculate. And there's our confidence interval. We're 99% confident that the true mean birth weight, or that this interval contains the true mean birth weight of babies born in the U.S. So between 3,285.8 and 33,580.2. It reminds you of what that x bar is and what that n is again, so that you can report that when you're writing a report or whatever. But we put those in there, so we already knew what those were. Again, we're pretty sure that this interval contains the true value of the mean birth weight of babies born in the U.S. between that many and that many grams, and that's what these confidence intervals do for us. Gives us an idea not only of an estimate based on that sample, but how good that estimate is, or how far off that estimate might be, is what this confidence interval is good for. Okay, so again, when we're calculating a confidence interval for the mean, for mu, for the population mean, given a sample mean, we'll use ZInterval as long as we know the population standard deviation. And the way that you can remind yourself of that is when you go to ZInterval, the very first thing that it asks for is that value of sigma, the population standard deviation. All right, in the next video we'll see how to handle that if we don't know the population standard deviation, what our workaround for that will be.